Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 55, X.509 Certificate Rotation, Why TLS is Still a Pain Point. Our guest today is Ben Burkert, co-founder and CTO of Anchor. Welcome, Ben.
Hey, Mike. Thanks for having me.
And maybe before we dive into TLS, you could just give us a quick idea of your background.
Sure. Yeah. I got started. I kind of got really into Ruby and Ruby on Rails around 2007 or 8, and that kind of led me out to the Bay Area right when the cloud computing stuff was really taking off. Ended up working at a Ruby hosting company called Engine Yard, and really kind of fell in love with like backend, the challenges of cloud hosting, hosting apps, that sort of stuff. From there, I moved over to GitHub, another really big Ruby on Rails shop. Worked a lot on like GitHub Enterprise, the early versions of that. Kind of started getting really interested in encryption while working on GitHub Enterprise and kind of dealing with, well, how do we create a licensing payload so that we can make sure that people have seat limits and that sort of stuff.
At GitHub?
At GitHub, yes, yeah, and dealt a lot with
And by the way, it's the best value on the internet. Like whatever we get charged, the minimal amount we get charged for GitHub compared to how much we get from it, it's like the best deal on the internet.
Oh, totally, yeah, for sure. Yeah, it's one of those tools where I don't think I'll ever stop using Git and GitHub. Yeah, I kind of I really just got really into the innards of encryption and that sort of stuff. And then from there, went over to Cloudflare and worked on data and some security stuff over there. And they were doing really interesting stuff with, they were handling TLS at scales that, nobody else is other than the other CDNs. They were doing some really interesting stuff like keyless SSL, where they could actually split up the kind of private key for the TLS connection. They could move it to a different host so that their front end servers could still terminate TLS, but the actual key data was being stored kind of offsite. Saw that they were doing some really interesting stuff with TLS, but still hitting challenges with internal CAs, CA maintenance, certificates expiring. I got woken up at midnight a couple times because certificate expired and everyone forgot about it. Yeah. I mean, yeah, it's like the age old story. It's like everywhere I go, it happens. It's like whenever a PagerDuty alert goes off, it's the first thing I'm thinking is like, what certificate did I forget to renew?
My first thought is certificate. My second thought is add a database index.
Yes. Yeah, for sure. Yeah. Those are the two. Kind of kept after that, moved over to Heroku, did some really worked on like the networking layer, the TLS layer there, Heroku's load balancer. And then, I just kept running into this problem over and over of like internal CAs just kind of losing sleep over them, either through alerts or just the kind of being a mess that none of the engineers wanted to touch.
And more servers doing secure communication, i.e. TLS exactly. Everywhere.
Exactly. So. Yes. Yeah. And, stuff like ACME kind of happened at the same time, and Spiffy, and some of these real cool innovations in TLS. And that's really what led me and my co-founder to say, like, there's this real pain with internal TLS, but it's becoming more and more important. So maybe we should try and solve these pain points that we keep running into. And that led us to start Anchor.
So we did an episode on Spiffy a while back, but I'm not sure my audience actually knows ACME. So for all sure. We try and explain the acronyms. If you don't know what ACME is, it stands for the Automatic Certificate Management Environment. And it's actually a protocol that helps issue and update certificates. For example, I think it came out around the same time as Let's Encrypt, so it became a way that you could implement in a language like Python, could implement this protocol and really help you automate sort of the provisioning or issuance of Let's Encrypt certificates. But what are some of the gaps? So ACME did help a little bit, but there's still some gaps. What are some of the gaps you would say that ACME left for developers and deployers?
Sure. Yes. Like you said, ACME, it's RFC 8555. It's an open standard for talking to a CA and requesting a certificate, basically proving to a CA that you own a domain and you're allowed to have a certificate for it. It's pretty amazing because if I'm sure you remember what it took to get a certificate pre-ACME days, it was a lot of like emailing, like, hey, go run this command on the command line. It's like this open SSL command that has like 20 different arguments and none of them make sense. And then that
I
spits out.
started an ISP in 1995. So yeah, I remember the idea of like, oh, just get a 10-year certificate.
Right.
This is such a pain in the neck.
Yeah. 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 Do it once and you'll never have to think about it again. And then when 10 years rolls around, it's like, oh man, what do we do now? Like that's
just made it worse. Yeah.
Right. Yeah. And it was a kind of terrible process. So you would do it once and then like immediately forget how you did it. And then a year later you'd remember because your website, the certificate expired and everything was on fire. ACME Let's Encrypt really came out of, I believe it was one of the open foundations for kind of encryption on the public web.
Yeah, was it the Internet Society that did it?
Yes. Yeah, and they spun out of another 501c3. I don't remember.
We're probably botching this. ChatGPT or Google will tell you in 5 minutes. Sorry, Let's Encrypt, guys.
Right, and so they had this Let's Encrypt when they got started. They had this directive of like, let's make encryption on the public web like free and accessible. So to do that, they needed to give away certificates for free because it shouldn't cost $100 for you to secure your website. And in order to give it away for free, they had to automate the entire process. So they created ACME to do that. ACME is that kind of codified REST API that you can talk to a CA and request a certificate. And it's great because they also built tools like CertBot, where CertBot's like a client you can use on the command line to request a certificate. So instead of that crazy OpenSSL command, now you've got like a really nice, like modern Python little CLI that's it's great for that. So ACME totally automates the process of provisioning certificates from the CA's point of view. From you as a requester of a certificate, it's still a bit manual. You still have to answer what's called a challenge in ACME. Those CAs need to be sure that you actually own the domain for the certificate that you're requesting. And in order to do that, you have to kind of fulfill one of their challenges. So a challenge might be prove that you own the DNS of this domain by publishing a record with a little value that we expect it to be, or point the DNS at set up a little HTTP server that will respond with this little challenge if I make a request to this endpoint. So those parts are a little bit manual still. But in terms of like where it was pre-ACME, it's like a giant leap forward in terms of like automatability. So we're in a much better place. But there's still some pain points when it comes to internal TLS. For one, ACME is just not as widespread for internal TLS tooling because I believe it started in 2015 and it didn't get ratified as an RFC until 2019. So it's still rather new. And the tooling just hasn't really caught up to it to kind of incorporate it.
Right. Now it also, ACME doesn't really help you on the consumption side. Browsers ship with a bunch of trusted root certificates, but in the MTLS world, trust is more explicit. So what are some of the challenges around, deployment and operation and just knowing like, okay, fine, the server has the right certificates, but what about the consumption side?
Totally. Yes. The way we think about this at Anchor is there's really two problems with internal TLS. There's the provisioning problem, which is getting certificates onto your servers, loaded into your server so that they can kind of terminate TLS. And ACME is great for that. It more or less solves the problem. But there's this other second problem. We call this the distribution problem. It's getting all of your clients to trust the certificate that's being presented by the server. When we think about how TLS works on the public web, this problem is more or less handled entirely for us by what's kind of it's referred to as a few different things. Usually it's called like the root trust programs.
Yeah.
There's really not good terms for this, but basically there's a consortium of browser vendors and operating system vendors and CAs. They kind of get together and self-regulate like web PKI and CAs on the public web. And so they say, you know, these are the rules that a CA has to abide by in order to be like a legit CA. And if they're legit, then they get to be bundled into browsers and operating systems. And so this bundle of certificates,
browser CA mafia, maybe.
Browser CA mafia, yeah. It's much better than the previous CA mafia that was charging way too much money for certificates. It's a good mafia, I would say. It's a really good thing that this organization exists and that they're building these certificate bundles, and end users don't have to.
It's easier to get trusted root CAs into the browser than it used to be. It used to be like you had to pull a lot of strings and know somebody to get a browser, a CA in the browser. Yeah. Yeah,
you still might have to know some people, but the kind of criteria is written down. There's this group also called the CAB Forum. They've got like documents that say like, here's what you have to do to be a legitimate CA, and here's what you can't do as well, which is important. You can't issue 10-year certificates, for example, anymore. And so, you know, they kind of build these certificate bundles. The curl project has a really nice way to just fetch kind of the latest certificate bundle for public CAs. But there's no like organization, or there's no mirror to that for internal TLS. So if you're an organization running your own internal CA, you have to basically duplicate this work of updating all of your clients with a bundle of trusted root certificates. And to make matters worse, there's really no common APIs for how these certificates kind of get loaded or just distributed. Typically, they'll go on the file system in like well-known paths. So one version,
CA certs in Java.
CA certs in Java, yeah. Different formats as well. I think you know, like even the browsers have different like database formats. This stuff is really messy, and so you know you've got a container image that has one file path for the CA certificates and another container, and then you've got like languages have their own idea of where CA certificates can go. Like Python, I believe Python. Some languages like to ship their own CA certificates,
right?
And so it's
like
really
Java
kind of,
also.
Java does
ships their own. You have CA certs comes with your JVM, and then you add to it. And yeah, no, it's a mess. I actually used to make a living because I was the only one who knew how to like convert between these certificate formats. And I was like, there was one job I had where I was the only one who knew how to get certificates into RACF.
Oh, nice.
But yeah, it is a real nightmare. So just like dealing with the formats is a nightmare, but making sure the right certificates that you actually trust are in there is and these are root certificates, though. They're not individual certificates. But even so, this is really a trust management problem that maybe even has some business aspects to it.
Absolutely. Yes. Yes, that's absolutely true. You know, our model at Anchor is we try to take on this problem and solve it for you. So Anchor provides fully managed, hosted internal CAs for you. So it's a bit like Let's Encrypt, but just for your internal TLS. So we give you an ACME API, makes it really easy to provision certificates. We'll also build packages, language and system packages. So you can get like a deb package that will take your internal roots and then install them into the container image or the system you're working on. And it is like, it's a messy problem and we have to deal with all of the mess. But we really try to like kind of wrap it up for you so that you're just thinking about like, you're just thinking about a regular app dependency update in order to get these root certificates. And then you can also, you can basically implement kind of policies to say, well, this microservice is allowed to talk to this one, but it can't talk to this other one over here. And you can start to build those sort of policy decisions into your CA deployment. So you can make sure that, hey, your staging systems can never talk to a production system. They'll never be trusted by a production system, and vice versa. and start to build those kind of RBAC style policies into these CAs.
Sounds a little geeky, to be honest, but I mean, I think that what you're talking about is more of a multi-layered security approach.
Exactly.
Where you're saying something like, well, I know production certificates
Yeah.
should never be used in development, or the other way
Bingo.
around. And so it's more like a multi-layer filtering approach. I actually wanted to take a step back, though. You mentioned about proving that you have controlled the domain by maybe adding a DNS record or something. And I was intrigued because one of the trust innovations that you mentioned in a previous podcast was the ability to use an access token as proof of control of the domain.
That's right.
And can you maybe talk a little bit about how this helps automate and how that works exactly?
Sure. Yes. There is this kind of in standard ACME, when you talk to a public CA, there is this kind of slow workflow you have to work through where you say, I'd like a certificate. They say, okay, prove that you own this domain. You say, hey, I've you got to use your DNS library to go insert a DNS record. And
that could be a different team, by the way. Whenever
that could be a different team.
In a large company, that's definitely a different team than you are.
Absolutely. Yeah. Yes. And so this is like, this can be multiple minutes. This can be an hours kind of workflow process that you have to go through in order to get a certificate. That's really, that slows things down like tremendously. And so you kind of still, with a public CA, you typically like, you don't provision very quickly. You kind of reuse certificates because it can still be very expensive to provision certificates on your end. ACME itself has a feature that's part of the RFC standard called EAB tokens. They stand for external account binding. And it lets you basically map an existing account that you have with a CA to your ACME workflow that you're going through. So it's a way to pre-authorize your API requests or your workflow. So you're saying, I want to get this certificate with this domain name, and here's my API token that proves that I'm already allowed to do that. And so with EABs,
is that token a JWT?
It is, yeah, JWS. Yes, which is a JWT, I guess. Yeah.
And so it's signed, and
it's signed.
And you're weird into this weird catch-22 where you have to validate the signature. So I guess this is a parallel where actually I want to connect this back to OAuth, but sure. I really love this idea because it's way easier to mint access tokens. And I bet that allows you to create a much faster provisioning process for developers.
Exactly. Yeah. One of the advantages is that you can really treat certificates and the private keys that are paired to them as ephemeral. With one of these EAB tokens, you've probably already got a secrets management system. You're using like a Kubernetes secrets management, so you can get secrets into application processes, containers. You can get API tokens into those containers. And then with EAB tokens, you can basically use that EAB token to bootstrap your certificate and private key. And that certificate only needs to live for the life of that server process. Once it's done, the next container, it's going to get that EAB token again, and it could just bootstrap a new certificate using that same EAB token. So this lets you kind of move certificates from these very long-lived things that have to be carefully managed externally, sometimes between teams, to something that really just lives during the life of a container and is way less kind of sensitive or feels much more ephemeral and confined or scoped from a security standpoint.
And is actually more secure just by the nature of it being shorter lived.
Yes. Mm-hmm. Yeah. Typically, public CAs will issue certificates for 45 days now. Some of them will still issue for up to a year. I think they're dropping the total lifetime a certificate can be valid. The CAB forum is, but it's getting shorter and shorter. Right now, kind of 45 days is a good number. But with this workflow, you can really get it down to a matter of days or weeks. So we typically start people off at 4 weeks for a certificate lifetime, and then we renew at 2 weeks. So these things are happening, are rotating pretty quickly.
Right. at OpenID, in our auth server that we developed at Glue and Johnson project, we use 2 days as the default key length, key rotation, and it's good because it's not about security sometimes, but it's about breaking developers quickly, so that if they forget to handle key rotation, they know pretty quickly that they got to do this, not maybe before they finish that project. And in the identity space, protocols like OAuth and FIDO, they require TLS. Actually, you must use TLS.
Right.
And so this creates some challenges around developers creating local environments.
Yeah.
And I heard you advocating for dev prod parity. So I guess making sure your development environment and your production environment are the same for developers. But still, it's hard for developers to actually set up all the tools for just to get that TLS working. Can you talk a little bit about some of the tools that you developed at Anchor that help make that easier?
Sure. Yeah, that's exactly right. Dev prod parity. A lot of times when it comes to encryption, developers will overlook that kind of parity with their production system. And there's lots of good reasons. This TLS, these CAs, they're hard to set up locally. It's this stuff is still, kind of still left over from the 90s as like kind of the workflows we have. So there are some good tools out there for like setting up a local CA on your system. There's a great one called MakeCert or MKCert. And it really just helps you set up a CA that can sign certificates for like localhost or star.localhost. And then it manages installing them into your browser and your operating system. But they don't really, they're very, a lot of these tools are very like focused on your single system. They can get your single host system that's running your browser set up. But if you're running your applications in like a container or you're starting to go across the network, this is when these tools break down. So at Anchor, we've built a tool that we dog food called LCL Host. It's kind of taking the idea of MakeCert or these local CAs and kind of doing a hybrid model with like a Let's Encrypt or a public CA where it's still a tool for getting TLS locally, but the CA is hosted externally. Anchor builds and hosts a CA for your development environment. And so you can have a process running inside a Docker container, and it can provision a cert via ACME, and it actually doesn't need to be trusted by that little container, but your browser can talk to that server, and your browser has the root certificates trusted because our CLI tool helps you kind of set up your browsers and your system. So it really allows you to get that kind of dev prod parity with encryption without it being something that everyone on your team has to kind of repeat the same steps and know how to manage a personal CA. And because it's based on ACME, you can build it into your application so that whenever your server boots, it just automatically gets a certificate, and that certificate renews after 2 weeks and kind of automates the whole process for you. So if you've got folks on your team who aren't as savvy or sophisticated with TLS, but they could really benefit from using TLS if they're doing something with FIDO, like you mentioned, it's really easy for them as well to use these kind of tools. That's the idea.
So Spiffy uses an extra certificate extension called subject alternative name. And in that they put the Spiffy ID. How does that work with Anchor? Like, can you define extra information about these certificates that you're generating, or is that built into ACME? Like
right now,
how do you manage the data in the certificate, I guess?
Yeah, that's a great question. ACME itself does not say anything about the extensions on certificates that you're using, other than the subject alternative name. It does ask you to use that one, but that's pretty much standard these days. Any certificate you get from a public CA is going to use the SAN extension. And actually, the CAB forum I mentioned, they're really pushing everyone to move in that direction. in terms of extensions, we don't support custom extensions out of the box, but we do use our own extension. And we plan to allow you to use your own extensions in the future. Extensions like Spiffy, so that you can say, I want to provision the certificate, and I want to kind of inject this metadata. Maybe it's like structured JSON, or just the Spiffy. Spiffy is JSON. Whatever kind of structure you want. I want to. So you can do things like, here's my grants, or my policy sort of tagging that you can add to certificates. We don't support it currently. We do plan to do it soon, because this stuff is really important for machine identity, especially Spiffy. We have our own extension that we add to all of our certificates, and it allows us to identify anchor certificates on your system, so that we can say, here's the certificates on your system that we care about. It's the certificates that have this anchor extension. And if we detect that, we consider it one that we manage with our tooling. If we don't see it, then that certificate is just not important to us.
So a lot of the certificates we're talking about are web certificates, but of course, other applications are using certificates in different ways. I'm curious if you've seen any growth in non-HTTPS certificate usage, and what are those areas, maybe, because you have an interesting view of certificate usage. What are some of those areas you see growth in?
Right now, we're totally focused on TLS. It's like a big enough nut to crack for us. But you're right. Like there's a lot of interest in bringing certificates to other areas, code signing. The SigStore folks are doing a lot with that. I believe SigStore is I believe it kind of operates like a CA, where it's a way of doing SBOMs and saying, here are the artifacts that went into this artifact that I'm building, and it's signed in a way that's verifiable. I believe using X.509 certificates kind of the same way, but it's not a public CA. And certainly like IoT is doing a lot of stuff with certificates. I think, certificates themselves are, it's funny. It's like, there's certainly better ways of kind of encoding and designing certificates than X.509. I mean, X.509, the standard started in the 80s. JOTS, and you can actually, there are parts of JOTS that use X.509 as well, so you can kind of mash these two things together if you really want to. There's a lot of innovations that you can do with certificates. But really, when it comes to TLS, it's going to be a long time before we move beyond just kind of how certificates as they currently exist are. So we think there's they're only going to be more important, and they're not going to be disappearing anytime soon. So that's why we're really focused on TLS and X.509 there.
Okay. Now we talked about shorter expirations, but revocation is still a thing too. Although it's mostly for these things like smart cards than it is for
BIP standards.
For web TLS connections. I'm just curious if you had any thoughts on revocation. Is this one part of PKI that you're just like, no, we don't need that? Or is there any use case for revocation?
We do need it. I think it's one of those things where we do have to do it. And so we do support revocation and OCSP. I think the consensus in kind of the security community is that short-lived certificates is really the best way forward out there. But at the same time, Web PKI is moving away from OCSP and moving back to CRLs and certificate revocation. CRL stands for Certificate Revocation List. It's in the same way that a certificate is a signed document, a CRL is a signed document that says these certificates are no longer valid. Do not trust them. And you have kind of the same distribution problems where you have to revoke a certificate, And then you have to distribute the CRL to everywhere that says, don't trust that guy, don't trust that certificate.
Right. And OCSP, for anyone who doesn't know, is like a DNS-like distribution system for CRLs. And hopefully you'll never run into it, because it is sort of obscure and esoteric. Yeah.
It's gnarly. Yeah. And actually, it's interesting. We actually kind of found an interesting use for OCSP. If you've heard of Caddy, the web server, it's kind of like a newer generation of like Nginx, let's say. It's a reverse proxy load balancer, but it's very modern. It has ACME built in. It's got like some really cool features, and it's got really great ACME support, including OCSP support. And OCSP, like you said, it's kind of like a DNS check. You can basically use it as a heartbeat to say, is this certificate still valid? And so you make like an OCSP request to a OCSP server, and it sends back a signed response that says, yep, still valid for the next hour or the next week. So the intent behind OCSP was to use that for kind of revocation or revocation, but you can actually use it as a heartbeat, and a server can basically heartbeat its certificate and say, hey, is my certificate still valid, or did somebody revoke it? And if they see the bad OCSP response that says, no, it's no longer good, they can do another ACME workflow and get a new certificate. So if you're at a company, the typical situation in a company is like someone leaves, you need to quickly rotate all of your secrets. You can actually use OCSP as that kind of mechanism to inform services that, hey, it's time to rotate your certificates and your keys.
Interesting. No, I'd never heard that. I'm not sure what I think of it right now. So
Yeah.
think about that.
Yeah, it's there's definitely some privacy concerns with OCSP, and that's a big reason why the browsers and WebPI are moving away from it. And it might be one of those things where in 5 or 10 years it's really sunset. And who knows where we'll be at that point.
Yeah. So you mentioned one of the podcasts I heard you talking about, there's a certificate ledger to enhance transparency for public certificates. And I hadn't really heard of that. And I'm just curious if you could talk a little bit about that, like what it is and how it works.
Oh, sure. Yeah. So there was this problem with CAs that they ran into in around 2011 or 12 that really led to the creation of this stuff. I believe it was Symantec, but I don't want to throw them under the bus or anything. Basically, at one of these CAs, an employee kind of like unknowingly used a valid root CA certificate to issue a test certificate. And being a developer, they thought, well, what's like a common domain? I'll just use Google. I'll just issue a certificate for Google because, everyone tests against Google. Why not? So this certificate somehow leaks out. And so there's somebody out there with a valid certificate for google.com that would be trusted by every browser and operating system out there. This is a huge problem for Google. So the folks at Google, take this very seriously. They put some thought into it, and they come up with certificate transparency logs. And so it's a way of CAs to basically audit each other. Every CA now has to, every time they issue a public certificate, they have to publish an entry into this log that says, I issued a certificate for google.com or benberker.com or whatever the domain. And then the log is also signed. So it's a bit like Git or Bitcoin or whatever, where it's like this series of signed entries, and it's publicly available. So every other CA or every other browser, Google themselves, can monitor these certificate transparency logs and know right away if one of these CAs issued a certificate for google.com or whatever domain they care about. And then so it's the kind of the second half of that is like, well, why wouldn't a CA just not issue? Why wouldn't they just issue a certificate? A rogue CA could issue a certificate for google.com, but not update their certificate transparency log. And so the second thing that monitoring these logs is all about is that if a browser vendor or operating system vendor sees a certificate that doesn't have an entry in a certificate transparency log, that's a big red flag. That means that a CA is probably not including every single certificate in their CT logs. So that's just as bad as issuing a rogue certificate. So you have this kind of system that works through kind of this group consensus. Everyone's auditing everyone else, and Google and other, everyone's able to be reasonably assured that nobody is issuing certificates for domains that they shouldn't. And so the practical effects of that mean that every single time you or I provision a certificate, that certificate goes into this public ledger. And so what you see is that when you provision a certificate through ACME, about less than a minute later, you'll start getting probe requests on that domain. So whatever that domain resolves to, you'll start seeing like, /PHP requests for known vulnerabilities. So the bad guys are monitoring these CT logs. And if you're, this is publicly disclosable information. So if you're doing stuff like betafeature.mycorp.it or whatever, that stuff's out there, it's discoverable. So you can end up leaking information about your infrastructure or your customer list kind of unknowingly just by provisioning certificates.
Interesting. By provisioning public certificates, not private certificates.
Bingo.
Yeah.
Bingo. Internal CAs don't have the same requirement to run certificate transparency logs. So a lot of the private CA products just don't even do it because they've got other ways of auditing certificates that are being issued.
So the federated identity industry, let's say, we have a lot of the same issues around, we're entirely reliant on TLS, first of all. And but then we also are minting things that are signed and rotating keys and facing a lot of the same challenges. And I'm wondering if you see any opportunities. I'm putting you on the spot here. I have no idea if you do or you don't. But I'm wondering if you see any opportunities in the federated identity space for some of the lessons that were learned in the TLS certificate management space. For example, OAuth, SAML, OpenID, and how key management and certificate management happens there.
Yeah, I think a lot of the kind of lessons learned from X.509 and TLS are pretty well addressed by I guess I could call them like the newer generation of these like signed credentials. Not that they've always been around, but like OpenID, these things are more recent, JWTs as well. And so, some of the problems with the big problems with, let's say X.509, let's start there. X.509 is a standard from the 80s. It uses a encoding called ASN1. I'm going to get like really into the details for a second. ASN1 is basically protobuf if it was written by a committee in the 80s. It literally came out of like this organization that is part of the UN, but also predates the UN by like 100 years. It's like a telco consortium international. So they create ASN1. It's a way of encoding binary data. And it's just a mess. There's like a dozen ways to encode a string into an ASN1 like document. It's just, they threw everything in there. And all of the parsers for ASN1 have been written in C for a long time because it's such a gnarly spec. So like memory vulnerabilities, all of these issues that modern standards kind of have learned from, we still have to deal with them with X.509. We still have to deal with like the mess of ASN1 and these old encodings. And then moving over to TLS, TLS was really the first widely deployed encryption protocol. And there were some things that were kind of known at an academic level, but not really at a practitioner level, let's say. So things like, do you sign the clear text before you encrypt it, or do you encrypt it first before you sign it? So TLS got it in the wrong order. And it's kind of an ongoing issue. We can't really correct it. We just have to, we're just aware of this flaw. But there's much more, like kind of going back to the encryption used by identity standards. I think they've really done a good job kind of learning from the deployment issues of both TLS and X.509 and Web API in general. So yeah, I think it's a much better story there.
Interesting. Well, we're coming up to the end. I like to actually end these things on time. Did you have any last thoughts?
I would say if you're interested in using HTTPS locally, you should check out lcl.host. It's a great way to kind of get up and running with local TLS, and you can use it to explore things like internal TLS if you want to do service-to-service TLS and play around with that without having to go through the pain of like bootstrapping your own CA and learning about all of the different various commands that the OpenSSL toolchain gives you. So check it out, lcl.host. It's a free tool that we've released at Anchor and makes it really easy to get local HTTPS.
I will actually put a link to that we have a wiki page, a GitHub wiki page for each episode. So I'll add a link into that. Yeah, I really like the approach. And I do think that this is a huge pain area that we see like literally every day at Glue. So yeah. So thank you so much for joining us as a guest and giving people sort of a starting point in the topic. You can go deeper on Anchor's website, and we'll give you some links. So thanks, Ben, for joining. Thanks, audience.
Cool. Yeah. Thanks for having me. This was a great conversation.